Okay, we are now live. In this live videos, we're going to solve this coding interview question, largest subarray with zero sum. The subarray must be contiguous. It cannot be non-contiguous. It must be contiguous. This problem states that given an array having both positive and negative integers, the task is to compute the length of the largest subarray with sum 0. For this given input, the length of this array is 8, and you're given this array of integers. This is an unsorted array. We have here this subarray minus 2, that sum up to 0, the length is 2. We have to find out the longest or the largest subarray with sum 0. So here we have this subarray with sum 0. So we have to find out the length. We don't have to keep track the subarray. We have to find out the length of the subarray. I hope you understood. Now, here we have a constraint. We have to solve this problem in linear time and in linear space complexity. This is the constraint. Now, let's see how to solve this problem efficiently. Before moving to the solution part, let me check whether this live video is working on my phone or not. If you guys watching this video, let me know whether this live is working or not. Write a reply on the chat forum. Let me check it on my phone. All right. I think this live video is working. Now we can get started. Let's move to the solution part. All right. Now let's see how to solve this problem. So first thing, what we can do, let's talk about the brute force solution first. The brute force solution. In the brute force solution, what we will do, we will use two nested for loop. We will use nested for loop. A pointer will point to this, and j will point to this. Okay, let me show you how to solve this problem in using our brute force approach. So first I is pointing here, j is pointing here. Now let's calculate the summation here, 15. Then let's move j here. Let's calculate this summation, that is 13. Let's calculate and just move on like that. And we will check, we will generate all possible, subarray, contiguous subarray, all possible contiguous subarray using two nested for loop. And we will take the maximum subarray. We will keep track the length of maximum subarray if we find out the sum of our current subarray is 0. But this is a brute force solution. This solution is not accepted by the recruiters. This is kind of a warm-up solution. In your interview settings, if recruiters gives you a questions, first thing you have to try your brute force solution. If you came up with efficient solution at the beginning, that's not a good thing. Recruiter will measure your signal, how you solve the problems, how you think, a lot of other signals. So first you should talk about brute force solution. And the brute force solution will take O of n squared time complexity. The space complexity is constant because we will not use an additional data structure. But this is not efficient. So how we can solve this problem efficiently? Let's see how to solve this problem in linear time and in linear space complexity. In order to solve this problem in linear time and in linear space complexity, we will use a hash map data structure. Hash map stores key value pairs. Let's assume this is our hash map. In our hash map, we will store key value pairs. As key we will store the sum. As key we will store the sum. Okay, so key we will store sum, as value we will store the index. So this is for sum and value for index. Okay, let me show you how. We will scan this array just once. Initially we have sum equals to 0. So we will scan the array using in loop. So I will point to the first element. Let's calculate the sum. So sum equals to 15. Does 15 is 0? No, 15 is not 0. If we don't find 0, what we will do, we will just insert this 15 in our hash map. Before that, we will have two conditions. Does sum is 0 or does sum exist in our hash map? That's very important. Also, we'll have a variable called length. So let's write out sum right here. Sum equals to at this point 15, and we will have length. So our answer. So let's call it max len. We can say max len, or let's call it len just. Length equals to initially 0. Now we have sum equals to 15. Does 15 equals to 0? No. Does 15 exist in our hash map? No. So we have two conditions. First we check whether sum is 0 or not, and then we checked whether this 15 exists in our hash map or not. So now what I'm going to do, I am going to just insert 15 right here in our hash map. We know that hash map is unordered. It doesn't mean if we insert here 15 will be right here. It can be anywhere. It's unordered data structure. Now we're gonna insert the index. So we calculated 15 at this point. So let's write in the index number 0, 1, 2, 3, 4, 5, 6, 7. So we find out 15 at this point. So let's insert here 0. We have one item on our hash map. Let's move forward. We have -2. Let's add -2 to our sum. So sum becomes 13. Does 13 exist in our hash map? No. So let's insert here 13, and here the index already find out 13. That is 1. So we will have the summations in our sum variable. We will have nothing, but we'll just add sum. At this point sum equals to 13. At this point sum equals to 15, and here we'll have sum equals to 7, and so on. All right, let's move on. Let's move on. We'll explain the intuition. Now let's move I right here. Let's add 2 to our sum, which becomes 15. Okay, we have sum equals to 15. Does sum equals to 0? No. Does sum exist in our hash map? Yes, it does exist. What it means? It means that we have subarray. We have a subarray of length of sum 0. We don't know the length, we have to calculate the length. So we are storing the sum of contiguous. Here the sum is the sum of contiguous subarray. So here we have 15. 15 is the sum of contiguous subarray. So if we just removed 15 from our sum, what are we left with? We're left with a 0, and that is this part. Okay, I'm not sure that you're understanding or not this intuition here. So we have sum exists to, at this point sum equals to 15, at this point 13, at this point sum equals to 15. The total sum is 15. If we have here 15 and we see 15 exists already in our hash map, and this is sum of contiguous from index 0 to certain index, or to the index we have in our map. Okay, in our map. So we have the summation of contiguous. So here we have the summation from index 0 to up until the point whatever index we have for that summation in our hash table, in our hash map we can say. So here what I can do is that we can just subtract 15. If we subtract 15, we get 0. Since 15 exists in our hash map, so we have at least we have subarray, at least one subarray of sum 0. So we can get the length by subtracting the length of this, the index of our current index equals to 2 minus whatever value we have in our hash map, that is 0. So which is equivalent to 2. So now we'll take the max of 2 and 0, that is 2. Hope you understood at this point. Let's move forward. We have sum equals to, we have 15 equals to, we have 15. So we have we see that 15 exists, so we are not going to again insert 15 for this index. We have here at this point 15. We're not going to update the value here 0 with this value. We don't need that, because we are trying to find out the length of longest we are trying to find out the length of largest subarray that sums to 0. So we will not update it. If we update it, we will not get the absolute we will not get the largest subarray sum that equal to 0. All right, let's move forward. We have -8. Let's add it. It's become 7. Does 7 exist in our hash map? No. Let's move forward. Here. Oh, 7. Let's insert 7 here before moving. So 7, the index we got at index 3. We get 7 at index 3. So now I will move here. Let's add here. So we get 8. 8 does not exist in our hash map. So let's insert here 8. 8 and the index we get at index 4. Then we have 7, which is 15. 8 plus 7 equals to 15. Alright, we say 15 exists in our hash map. Exist. What it means? We have 15. So from index 0 to index 0, from index 0 to certain index, we have the sum here. All the sum started from index 0 to the index 1. All the index 0 to index 3. So we have a sum here from index 0 to 0 is 15. If we just exclude this, then what we will get here? We will get this subarray of length 5 that will sums to 0. Pretty simple, right? So what I'm gonna do here, we can find out the length. So 5 minus this index 0. So 5. So length equals to 5. Let's move forward. 15 already exists. We will not insert in our hash map. So at this point, we saw that we have sum equals to 15. We do not update. If we update it here, if we were updating at this stage, we will not get the length of this. Hope you get the point here. Let's move here. We will have here 25. 25 does not exist. So let's insert 25 here. Then here we have 23. 23 plus 25, and the index here is at index 6. Then 23 plus 25 equals to 48 maybe. Does not exist. So let's insert here the index 7. So we are done. I will point out a bound. We are done. We find out length equals to 5 at the end. This is the solution to this problem, and this solution will take actually of n time complexity, because we're scanning the array only once. We might have n number of elements on our hash map, so for the worst case it might take of n time complexity. It might take of n time complexity. This is the time complexity. This is for space complexity. We might have n number of elements on our hash map, so the space complexity is n, where n is the length of the given array. This is how we can solve this problem. Hope you have understood this video explanation. Now let's move to coding part. Let's implement our algorithm using Java programming language. Before that, let me check is there any questions in my in the chat forum. If you have any question, you can ask here. Do you have any questions understanding if you have any question understanding the explanation or the algorithm, please post your question here. I will be glad to answer. All right, so let's move to coding. Now I'm gonna code off this solution using Java programming language. So let's start coding here. We're given the array and we're given the size of the array. First thing what I have to do, I have to create a hash map data structure. So let's create it. Hash map. Hash map will store as key integer and as value integer. Let's call it map equals to new hash map. This is our hash map data structure. Now we have to create two variables, int len. length equals to 0 and sum equals to 0 as well initially. Now let's run a loop for int I equals to 0, I less than in I plus plus. This is just a regular for loop. Now inside, let's calculate the summation. Sum equals to sum plus equals to r I. Now we're gonna check if sum equals to 0. If sum equals to 0, let's compute the length. If sum equals to 0, we're storing the summation here in this sum variable. We have the summation from index 0 to index I. So the length is I plus 1, right? If we have sum equals to 0 at index I, because we're starting the summation from index 0. So here what I can do, we might have length here, we have to take the maximum. So length equals to math.max. At certain point, we might have length is greater than our current sum. So I plus 1. All right, so this is our this is the case for when sum equals to 0. Now, else if we saw sum exists in our hash map, if map dot contains key, if the key contains, if the sum exists in our hash map, then we have to compute the length of our subarray. So length equals to math.max len, and our current index minus index we have in our hash map for our current sum if the sum exists. So this is the formula to for that. So I minus map.get sum. We don't have to use here plus 1 because this is one. This will points to the left of our left pointer or our left boundary for our current subarray. If sum is not equals to 0 and if sum does not contains in our hash map, we will just put in our hash map the sum and the index, and at the end we'll just return the length. This is the algorithm. Linear time algorithms and linear space. It will take linear time and linear space. Here I think that we can just use here I plus 1. For example, you can use length. I think I plus 1 should work. Let me check it first. If it works, it's okay. If it will not work, we'll change it. Anyway, now let's run this code. Compile it. All right, it's working. Let's submit it. All right, it passed all the test cases. This is the algorithm. Hope you have understood how to solve this problem. The time complexity is linear, where n is the length of the given array, and the space complexity is also linear. All right, so I hope you have understood these video explanations. On my channel, Subarray, there are not a lot of viewers viewing the channel. I currently started working on the channel full time. I'll try to go live irregularly, and I'll try my best. I plan to create a course on data structures and algorithms for coding interviews. If you guys want to see the course on the channel, I need your support. If you support me, I will try to give my best. If you want data structures and algorithmics course on the channel, then just post your just support me by just replying or by just commenting on this video. If I saw some comments, I will surely start creating a course on data structures and algorithms for absolute beginners. And yeah, so in the channel, I primarily focused on Java programming language. I use Java programming language to solve problem. If you guys want more video like this, if you want a specific problem solution videos, just comment on this video. I'll try to record that video. All right. If you are trying to prepare yourself for coding interviews, then the channel going to be very, very helpful for you. If you want to crack coding interview at FANG, then the channel going to be help you a lot. All right, so if you have any questions, if you're preparing yourself, or if you have any difficulties understanding some solutions or any kind of problem, just let me know. I'll try to record that video on the channel. And I will go live. If you have any questions, you can ask me. I'll explain that to you. Still, if you have any questions on this problem, largest array with zero sum, I'm ready to answer you. This is okay. Now let's stop this live video right now, and I will see you in another live video. Till then, take care.